Graphing linear inequalities is just like graphing linear equations. And here we have a linear inequality, and the only difference between this and a linear equation is that we have an inequality symbol instead of an equal sign. So we're going to, for a moment, there's really basically three steps. The three steps of graphing a linear inequality. Step number one, just pretend for a minute that you do have an equation. So we start off with that. And so we start off with the idea, what about y equals negative 3x plus 2? If this, hopefully you know how to graph. And we'll use this as the boundary line for where we shade later for our linear inequality. Let's go ahead and take a look at how we might graph this. We might do something like such. And let's see here. Our y-intercept is at 2, so we start at about here, 1, 2, and we'll put a dot there. And then our slope is going to be equal to m equals negative 3, which is the same as negative 3 over 1 or 3 over negative 1. Those are all equal to each other. And that means that if we want to, rise over run is slope. We could rise negative 3 and run 1. So if we rise negative 3, 1, 2, 3, we could then go and run 1, and we would end up with another dot right about here. And then we just got to draw a line through there. And then the question is our line going to be solid or dashed? And that's where we get to step 2. In step 2, we're going to choose solid or dashed for our line. And in this case, because we have a less than symbol, we're going to say, well, because of that less than symbol, let's go ahead and make this line dashed. In other words, just like with the crayon before, since there's no crayon here, we will not make it a solid line. If there was a crayon there, then we would fill in the dashes and make it a solid line. So let's take a look. Let's go ahead and draw this line, and it goes a little something like this. And then the final thing that we do, step 3, is we'll go ahead and test to see where all the solutions are. Oh, and by the way, this line's supposed to be shaded, right? So let me see if I can erase that. So I just went ahead and I just erased some of this line to make it a dashed line because we have no crayon. Okay, so now let's go ahead and test. We want to test what is, where are the solutions? So, I mean, that's why we're graphing, is we want to know what are the possible solutions to this inequality. And solutions mean ordered pairs of x and y. In other words, it's values of x and values of y that make this inequality a true statement. That's what we're looking for. We're looking for these guys. And there's lots of them. So, let's go ahead and test. Usually what we'll do to make the math easy on ourselves is we'll test at the origin. We'll test that point 0, 0. Again, all that means is x is 0 and y is 0. That's all it means. And we'll just plug x is 0 and y is 0, and we'll see if it's a true statement. And if it is, it means that all of our solutions are over here. And if this is a false statement with 0 and 0, then it'll mean all of our solutions are over here. There's only two places where the solutions can be, either below the line or above the line. So let's try. So I'm going to go ahead and plug in, let's go 0 is less than, negative 3 times 0 is just 0 plus 2. And the question is 0 less than 2? And the answer is, yeah, it is. So since this is true, we'll say, hey, I guess what it means is that all of our solutions are over here. And one way to indicate that is you could just, draw a big mass of, you could just shade the whole area in if you want to. Or you could just draw arrows to indicate that there's solutions all over here in this area. What this means is if I go and pick any point at random, like this point right here, or this point right here, if I looked at the x and y values for this guy, what I would find is, for the x and the y, this x and this y would make this a true statement. And vice versa, if I picked a point over here, any point over here on this side of the line, and I plugged in the x value and the y value, it would be a false statement. So that's how you graph a linear inequality when you are given your linear inequality in slope-intercept form.